Hey everyone. I know you've been having very good discussions with among yourselves and the mentors. So I thought maybe we can take this little 20 minutes before lunch so that if you want to ask some questions in public, we can try to answer and maybe provide some feedbacks. I think Wei said that we need to have some repository for posting the answers, but I don't see the repository being used right now, so maybe we can just ask in this setting. So, any questions? Yeah, so I think there's a mic.
Hi. In the privacy-preserving weather app, where you send your encrypted location and you get back the weather report for that location. Mm-hmm. So my understanding is you search a weather database and retrieve the weather information for that location. If the database has report for, say, 1,000 locations, do you have to search all those 1,000 locations just to hide which location you actually want?
Yes, so the answer is yes. And if the database is very large, then it can be inefficient because then with the homomorphic encryption, the idea is that you need to hide which location you're interested in. So naturally, you have to go through every entry of the database. But one of the things that we can do as a potential trade-off between the efficiency and the privacy is that you can allow to reveal some information about the location, which is more kind of coerced. So for example, you can reveal which country you're in, but not the city. So in that case, you can just choose to focus on the part of the database that's specific to that country. So that's one way to reduce the overhead. Yeah, that's a good question.
So I want to clarify something a little bit more on that, which is that Hao said that if the database is very large, the performance can be challenging, but actually for that weather app, that kind of key value store, we can really go to billion-size data sets. So it scales quite well, even though you have to search it linearly, of course.
How long does it take?
Talking about some seconds, but it's still very, it's of course very parallelizable. So depends on how many cores you throw it. Yeah. But we're not talking about, maybe we're talking about a minute at most for some billion item size set. Of course, it's much smaller if you have a million elements. You can always shard, you can always leak some information, like I'm searching for weather in the US, and now your location, now your data set is substantially smaller.
Yeah, that's right. And I think one of the things that we can always explore is you can have this parallel processing at the server. So if you want to reduce the latency, that's the other way to do it. Yeah.
Okay. When considering a solution from like a technical point of view, does it have to be like 100% pure, non-interactive AG, or is it okay if you have, for example, so say, for example, you want to do stuff on like an IoT device, which is like connected to the internet all the time, then you might be able to like squeeze more power out of this by actually also making whatever computation you do like interactive. For example, you don't have to do bootstrapping, right? You can do that on the client by decrypting, re-encrypting.
Yes, so I think interactive solutions are fine, and there are some extra complexities that come with it. Then as long as those issues are addressed, then it's okay. So I can think of some of the possible additional issues for interactive solutions. So first of all, if it's kind of a two-party computation which involves sensitive data from both parties, then we need to make sure that this intermediate ciphertext that's going to be decrypted doesn't contain more information than what you're supposed to learn in the end. And the other thing about it is, suppose you're doing more like an outsourced kind of computation, then there's a trade-off between like how much you are willing to let the secret key owner do. Because if the computation is so lightweight and you're still doing a lot of decryptions, then even the decryptions can cost a lot of power. on the client device. So we want to kind of be able to manage that too. Yes. Oh, there's a question back.
I also have a question from the technical point where I think this might benefit everyone. So in terms of functionalities, I think so not a lot of people know about the seal code base. Like what kind of functionalities do we have? Like just a broader, there's a ton of functions, but add, multiply, like I think in that range and negation, you have all kinds of things. But above that, like so something like comparisons, like and all of that, like are they implemented? Will we have to implement them? Because some of these have been done for instance, cryptonets where you have polynomial approximations. They have been done. So are these available, like, or are we restricted to this sort of smallish set of things?
Maybe Kim can answer that one.
So actually in cryptonets, we didn't use a particular polynomial approximation. So in cryptonets, instead of using more traditional activation functions for the neural network, we used x squared, which works. In fact, we've done some experiments, and it works really well unless you go to maybe depth 10 or so. You get some instability from it. But in that case, we didn't have such a thing. Of course, the functionality in Seal is exactly what you see in the evaluator, and everything else you would have to implement yourself. But homomorphic encryption, the functionality is addition and multiplication. Now, of course, we have also these vector operations. Things like square root, for example, you can always do in the sense of a polynomial approximation. So you can, if you have a narrow interval, which you know it's some predetermined interval, then you can always fit a polynomial to that pretty well. Taylor approximation, for example, is usually a terrible idea. There's much better ways of doing this. Some minimax approximations, but yeah, that's how you would do things like square root. But again, you need to know where the input values are. So they're encrypted, and you're the evaluator, you're the server. You get some input now. Somehow, you just need to assume that you know where the encrypted values lie.
Yeah, so what I wanted to add is that I think, so you're right that right now we don't have a lot of support for the more advanced functions, for example, like comparisons or so. But I think there should be like given ways to do that. For example, if you do CKKS, then probably you can approximate the comparison function pretty well, and I think there's papers on that. And then I don't know, I think maybe building it from scratch on top of Seal may take too much time, but just having a sense of like what's the rough asymptotic cost of that operation that's probably sufficient.
And I think it's important to understand that you can get pretty good approximations with low degree polynomials, even degree 3, degree 7, so degree 10, but only in restricted intervals. Comparison, again, it's definitely possible with CKKS even, but it's only going to work in some specific interval.
Yeah.
And so if you think of the step function, and if you think of a polynomial approximation of that, then very close to the step, it's going to be not really working very well, but it's going to work well sort of slightly outside the step.
Yeah.
And I just remember that if you have to have comparison in the framework, maybe you can do it like gobble circuits and something.
Okay.
Yeah.
Hold on.
Sorry, just a sec.
Has there been any work on text-based models for FSC? Because I think most of the works have been on images.
There has been. So I think I just submitted a paper. I think there's a paper called Priv FT I'm on that paper. It's an archive, but I'm not sure if it's been accepted. But so there's been definitely some things like that. It's possible to do sentiment analysis, but what you would normally in these cases do is you would first use again some more generic, say, neural network to extract the features from the text, because you wouldn't. There's no point really necessarily in encrypting the text, the letters themselves, and somehow encoding them and then encrypting them. Instead, you would first extract some vector of features, which can be big. It can be 100,000 dimensional or bigger, but that's not the problem. And then you can run all kinds of sentiment analysis and other text prediction models on top of that.
Yeah, I think the generative models will be difficult because then RNNs, because you have to loop through it.
Yeah,
Classification should be easier.
Right. Well, RNNs are challenging.
Yeah.
Other questions? Oh, yeah.
Just to clarify, can we use other security primitives like GC or GMW, or it should be limited to HE?
So if you're asking me, I think if HE is one of the components of this whole solution and it's kind of like a crucial component, then I think it's okay. But I would double check with Wei.
Well, I would say, honestly, let me give my perspective on this. So I think all, like... Can you grab the handle? So while there certainly are a number of already published papers which can do hybrid, combining HE and GC, and I think that is a very valid research direction. I think if you think about the spirit of this workshop and what we're trying to do here, we're trying to build up kind of a core of experts that can actually handle homomorphic encryption operations using SEAL, and also to help to understand what are the limits of practicality. So for example, if you want to do comparison, already today, TFHE, which is homomorphic encryption, it just has a different system for encoding and encrypting. TFHE handles comparison extremely efficiently. Now, in SEAL, you can also encode and encrypt bitwise, which means you can do comparison. You can do exact comparison of anything you want. It's just not optimized for that because of the way that things have been set up, and that, the FV scheme, for example, is very good for floating point type of computation, and it's just not optimized for comparison. So instead of going all out and jumping to a GC-based solution or a hybrid solution, at least for this competition, I would recommend that you just think a little bit harder about how you can do comparison with the existing HE systems, and whether or not it's worth, for example, going back and forth between a TFHE representation and an FV representation using some approach like Chameleon or something like that. Those are directions which are less explored and which are more relevant to this workshop. So that would be my answer.
Thanks, Kristen.
Speaking as one of the judges. Actually, here, can I see?
Oh, yeah.
There's a question. There was a question from this group, and it just, I didn't know whether they were brave enough to ask it. And since I don't know the answer very well, I thought we should crowdsource it here. So there's, the Azure Run, for example, is collecting GPS. I was saying there was the Azure Run demo that I showed yesterday was collecting 3 things: GPS, accelerometer, and gyroscope. And this data, it could be sent up to the cloud at the end of your run. But the question is, how sensitive is the data that's being sent up to the cloud? So in terms of GPS location, if you were sending it as you ran, but you sent it in encrypted form, would the cloud then know your GPS location anyway, just from where you sent it? And so my understanding is that GPS location is pretty inaccurate, pretty rough. And so I wasn't sure how to answer that question. Does anybody know kind of a relative accuracy of GPS? Oh.
So as an application developer, they could choose the precision at which they do it. So that determines the number of pins the device sends in order to determine the location. For instance, they might use a last cached location that you could do with Apple Map Kit. Typically, wearable devices don't want to implement and upload to the cloud the exact location all the time. They do want to pin as often as they could because of the battery cost if you have GPS running in the background all the time. So that's the way it's being done right now. I don't know.
Great, I'm glad I asked. So maybe you guys can follow up and get more information and discussion about that point with Mimi.
Okay, I think we're 3 minutes to noon, so last question. I think in the afternoon we'll also have interactive sessions, so if you have come up with more questions, there's still a chance.
And we didn't assign fixed mentors for each group. Has every group received some attention from one of the leaders? Has every group been visited? So, no, not you guys. Okay, you're next. 3 groups. 1, 2, and what's the other group? 3. Oh, okay, great. Well, we will come and find you. Thanks. Another question?
Okay, thanks. Then let's conclude this session and let's go to lunch.